going to now continue from our previous discussion on the basic transistor construct and show you how the transistor now works inside of a circuit as just this basic operation. We're going to use the same three types of connections that we had with the previous instruction. We have the emitter, base, the collector, and this is actually the schematic symbol for what we're going to call an NPN transistor. The N part of this part talks about the emitter, the P is the base, and the N is the collector. We're going to use the same type of voltages that we talked about earlier, and we're going to talk about the currents that occur when this begins to conduct. In the first example then, we know that we had a positive voltage tied into the base and a negative part of the battery that connects down into the emitter. Know that current will begin to flow as soon as we have what's known as the base to emitter voltage of 0.7 volts. As soon as that occurs, the current can now go through this device. Let's connect in our collector supply. In the last example, remember that the positive part of the terminal on the battery connects into the collector. Because the collector to base is always reverse biased, this one is forward biased on the emitter to base junction. So this one right here is going to have the higher positive voltage tied to the collector, and once the forward biasing has occurred, we can now allow the electrons to flow out of this battery and go through the circuit as well. So the very first one, it's actually got two currents. One's called the base current, and that's flowing through the transistor. It's going this way, back around, comes back into here. We call this the forward biasing loop. The reverse bias loop is actually between the emitter and the collector. So once the forward biasing has occurred between the emitter and the base, we can now have emitter to collector conjunction as well. So it's going to go this way. It's going to come out of the negative part of the power supply. Oftentimes those go to ground on schematics. It's going to go down through here, up this way, through the emitter, across the base, and into the collector region and back to the positive terminal. And it too has a current, and it is actually called the collector current. We now have two currents flowing through the circuit. This is the base part of the current flow. This is the collector part of the current flow. In your book, you'll notice that they ask you to analyze these two particular currents, and they're going to call those the emitter current. The emitter current is the sum of the collector current, I sub C, plus the base current, I sub B. Consequently then, the emitter has most of the current flow into the device. As I mentioned in the previous instruction, the emitter current going up into the collectors is practically 99% of the total part of the power supply. Only 1% of that goes out into the base region, and because it's the base current. So when you add those two together, 100% of the current flowing through this device actually occurs as a result of the emitter current occurring, which is the sum of the other two currents. Kind of like branch current analysis using Kirchhoff's current law. Okay, once these are occurring then, there's also something that we're going to talk about in amplifiers called beta. I know it's in the same chapter, but I'm going to cover that topic in amplifiers. So at this point, we're pretty much done explaining the two different currents, how they occur in the transistor, and from there there can be all these other components, but the basic operation is still the same. They have to operate that way.